Ladies and gentlemen, the Inequality Review. Dun 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 dun. Come on and slam, and welcome to the jam. I need to go watch Space Jam. How's it going? How y'all doing? Today we are going to be reviewing the inequality stuff. We've had inequality stuff before. Ooh, I can make myself bigger. So this should hopefully be a review for you guys from what you've learned about inequalities in the past. So let's jump into vocab. Same words we've been seeing except this first one. This first one is a math sentence with unequal sides. That's what we're learning now, inequalities. Before, both sides were the same. That was an equation. Now, we're off balance. It's an inequality. They are not the same. A letter that represents a number is still a variable. Opposite operations are inverse operations like addition and subtraction, multiplication, division. Again, opposite being the key word there. To be alone is to isolate. We're trying to isolate the variable still. Same steps as before. Same steps as before. The multiplicative inverse, to get rid of a fraction when it's in front of the variable, is the reciprocal. The reciprocal. Then we have the number in front of the variable. So that'd be like the m when it's y equals mx plus b. That's the coefficient. The number that's by itself, the y-intercept, that b, that's the constant. And then the last word we have is those numbers with common variables written in similar form, the like terms. Hopefully you're getting more comfortable with these words. We've literally been seeing them since January. Hopefully we've got them down by now. Go ahead, pause the video if you need to. Otherwise, let's move on to the next section. Keywords for inequalities are huge because when we're writing the signs, if we're needing to say them out loud, we need to know what words to say. So first, we're going to start off with a sign that means is equal to. Well, that's obvious, right? If something's equal to something, it's going to be an equation. So there's my equal sign for an equation. If something's not equal to something, if it's not equal to something, what do you think I do to my equal sign? I put a line through it. It's not equal. You think about like when you see like a no talking sign, there'll be like a slash through it. Or no smoking sign, they'll put a slash through it. The next word is greater than. What does the greater than sign look like? Greater than sign looks like this. Greater than looks like that. A way that Miss Montero likes to think about it is the greater than sign has R's, so if I turn it into an arrow, it points to the right. Greater than points to the right. More than, exceeds, is over, is above, is larger than, is longer than, is higher than. Those are words that you'll probably see in word problems where you need this sign. But the way we would call just that sign is greater than. The opposite of greater than is less than. What sign or what direction does that sign point? Less than looks like this. Less than, if I turn it into an arrow, points to the left side. So in case you're confusing them, greater than points to the right, less than points to the left side. Ooh, there we go, that's better. That's better, Miss La Rosa. Again, if you see word problems, you might see is under, fewer than, smaller than, below, shorter than, beneath, lower than. All those words also mean that you're going to use the less than sign. This next one, they are very similar. Very similar to what we had before. This one is greater than or equal to. I know this is my greater than sign, but I have to add something more to it to get that equal to. I just put that line underneath. I have the greater than sign from before. One of those equal lines, it's like they had a baby. They put parts of each symbol together to show greater than or equal to. Keywords for that might be is at least, is not less than, is not under, has a minimum value, is more than or equal to. Those are all good keywords for greater than or equal to. Again, greater than, it points to the right side. So this next one is less than, so it points to the left side. Draw those arrows in there if it helps you think of the words. Less than or equal to has other keywords like is at most, is not greater than, does not exceed, has a maximum value, is no more than. All of those words mean is less than or equal to. A lot to keep up with, especially with those word problems. Go ahead, pause the video if you need to. Otherwise, let's go on to the next part. Inequalities. Again, like I said, we're going to be going through doing the exact same steps as before. There's just a few little things conceptually different about inequalities compared to equations. First off, inequalities have multiple answers. Before, when we were doing equations, I would see like x equals 2. X can only be 2, that's it. There's one answer for an equation. But if I have an inequality, like x is greater than 2, any number that's bigger than 2 will work. I could say 5. I could say 17. I could say 3,642.7. I could say 2.0001. Those are all bigger than 2. There are multiple answers that work there. So that's what I'm talking about here. Multiple answers that are involved in your answer. If we were to graph this x is greater than 2, would I use an open circle or a closed circle to graph this on a number line? Hopefully you said an open circle. For greater than or less than, we use an open circle, and we have to shade or draw the line just a little bit thicker, whichever way our answers go. So here, x needs to be greater than, x needs to be bigger than 2. So if I go out just a little bit more, this would be 3, this would be 1. Which direction shows x is greater than 2? The right, because 3 is greater than, it's bigger than 2. So I would shade like that. We used closed circles. When we have greater than or equal to and less than or equal to. I like to think if I have to be extra with my sign, if I have to draw that line underneath, then I have to be extra in my answer. So for example, if I had x is greater than or equal to 2, looks the same here, it's just my sign in the middle is a little bit different. For this, x is greater than or equal to 2. To show that x equals 2, we use a closed circle. If I was just graphing this for an equation, all I would do is just put a closed circle onto, that's it. Because equal means it includes that. That's what that closed circle means, it includes that number. Here, we're trying to include that 2 and everything bigger than it. So I would include that 2, and I would shade everything to the right, everything that's bigger than that 2. Jacko, get down, buddy. Sorry, just a second. He's trying to sniff all the TREATS off the top of his kennel. All right, pause the video if you need it. Otherwise, let's go on and see what's next on here. Oh, wait. We still have all that stuff right there. Hang on, Miss La Rosa. Hang on. I forgot to do this. The last thing that's special about inequalities, sometimes we have to flip the sign. That means if the sign was like this, if I do this special thing, it's going to get flipped and it's going to look like this now. Or maybe I'll have a sign that looks like this. And then if I do something with a negative number, I'm going to have to flip my sign. So now it looks like that. When do we flip our sign again? When we multiply or divide by a negative. Only multiplying or dividing by negative. Adding, subtracting, that doesn't matter. Only when we multiply or divide by a negative number. Now pause it if you need to, and we'll go on to the next slide. If you don't believe me, you can go ahead and pause the video and do this keeping it true activity. What you do is you start with a number, these two numbers, and it tells you what to do. So first, I'm starting with 2 and 4. I want to add 2. So 2 plus 2 would be 4. 4 plus 2 would be 6. Then I subtract 3. I would get 1. I would get 3. And I do that all the way down. And then what you would do is come through and draw this inequality symbol. So this first line, 2 and 4, I see that 2 is less than 4. And I keep going. 4 and 6, 4 is less than 6. 1 is less than 3. As you're going through these operations, you'll find out that the sign's going to flip when you do certain things. So that's why we're doing what we're doing. That's why we're multiplying and dividing by negatives causes us to flip it. So go ahead and do that activity if you're interested. Real quick review of the things we just talked about. I've said it once, it must have been important. If I'm saying it a second time, it must really be important. So remember, we flip the sign when we multiply or divide by that negative number. When we multiply or divide by a negative, we need to flip our sign. When we're solving, if we're graphing with the line underneath, remember, that means we include. That looks like indude. Hang on, I need to fix that. We need to include that answer in that number in our answer. Remember how we talked about with those ones, we have the closed circle? Because that means that number is counted in the answer. But with those signs, again, it's an open circle because we don't include that one. It has to be greater than 2. That does not include 2. So we do not include it. And again, multiple answers. The answer is going to cover a range of answers. There's a whole bunch of numbers that's going to cover. So it's going to cover a range of answers. Amos said something really good today. I don't remember what word he said, though. That was another really good word for range. Amos, if you watch this, remind me what you said. Okay, let's get into solving some one-step inequalities. One step. This is throwing it back to 6th grade. These slides look the exact same as what we've been doing, you guys, since January, because it's the exact same steps every single time. Same steps every single time. So we start off drawing our river of love. Before it went through the equation, because that separated the two sides. Now our river of love is going to go through our inequality sign, because that's what separates the two sides. So I draw my river of love like that. Go through, do my sad Meg. I see I've got that X. I'm trying to isolate it, get it by itself. So I need to get rid of my constant, that -3. What's the inverse of -3? Adding 3 to both sides. Draw my river of love. Now I'm going to add 3 to both sides. A minus 3 and a plus 3, that equals 0. They go away. I bring down my x. 4 plus 3 is 7. Do I flip my sign? No, we didn't multiply or divide by a negative, so our answer is going to stay the same. We have x is less than 7. Now we need to graph it. As you guys can probably see, Miss La Rosa did not make this graph long enough. That's okay. Just add on the 6 and the 7 at the end. We don't need to divide or multiply because we already solved, so you can X that one out. And here we see we have x, again, is less than 7. So does that mean we have an open or closed circle there? That's an open circle because I don't include 7. X has to be less than it. It can't be exactly 7. It can't equal it. So an open 7, x is less than, x is less than. So that means I need to shade to the left because all those numbers are smaller than 7. Now, let's talk about how we check our work here. So before we would make sure that both sides were the same because it was an equation. The equation means the same thing on both sides. Here, we have an inequality. We need to tell our calculator, first off, what we got for x. So we're still going to type x equals 7, even though we know x needs to be actually less than 7. But what we're going to check to see is this side smaller than that side? So if I do x minus 3 on one side, and the other side is 4, I see that yes, they are the same. Yes, they are the same, but I would just know that when I'm giving out answers, that x has to be less than that 4. X would need to be less than that 4. So it's good that they're the same number, but in theory, in practice, the actual number that we use for x would need to be smaller than 4. This next one, draw a river of love. Uh-oh. What operation is it when they're on top and bottom? That's division. So what's the inverse? What's the opposite of division? Multiplication. So I'd multiply both sides times 2. Multiplying and dividing by 2 eliminate. I bring down my x. 4 times 2 is 8. Does my sign flip? I multiplied. I didn't multiply by a negative, so it's not going to flip. It's not going to flip. Open or closed circle when we're graphing here. Again, Miss La Rosa did not make it big enough. Sorry about that. Closed circle, yeah, because it has the equal to sign. So I'd want a closed circle because my answer includes 8. 8 works. Then x needs to be greater than 8, so I shade to the right. Go ahead, pause the video. Try these next two on your own. Play it when you're done to make sure that you got the right answer, but try them on your own first. So this first one, you should get -7 is greater than r. I subtracted 4, so my sign does not flip. It stays the same. I should have an open 7, open circle on -7 and shade to the left because r is smaller than -7. Smaller numbers are on the left side. This right one I didn't graph yet because I wanted to go over that together. You're dividing by a negative, so you need to flip your sign. It was facing the right, open to the right. It was less than. I flip it, now it becomes greater than. So I should get that y is greater than or equal to -1/2. On my number line, -1/2 is going to be between -1 and 0. So I want a closed circle there. Y is greater than, so I'm going to shade to the right. If you have any questions on that, please let us know. Otherwise, pause the video, finish writing if you haven't. And let's go on to two-step inequalities. Two-step inequalities. Again, make sure we're going in order through our steps. We've got more now. So again, let's start off with our river of love. Again, sad Meg. First we subtract or add. Before, when we were seeing our coefficient with our variable, what did we do to help us remember to save that for last? We're going to put that box around it to protect it. We need to get rid of that constant first. So to get rid of that -3, we need to add 3 to both sides. 15 plus 3 is 18. I bring down my 3x. My 3's cancel. My sign does not flip. I did not multiply or divide by a negative. Now they're side by side. To get rid of that multiplication, I need to divide both sides by 3. Did I divide by a negative? No, so I do not flip. I should see here that x is greater than 6. X is greater than 6. Again, just extend that. I'm so sorry, y'all, that I did not get these number lines right. Open or close circle? Open. There's no line underneath. And what direction should I say shade? X is greater than 6. So I should shade to the right because it's greater than. If you like to rewrite it, x is bigger than 6, and then draw your arrow to see which way to shade, that's another trick to help you remember what direction to go. Or maybe just recognize that x needs to be bigger than 6, so I shade the numbers bigger than 6. Whatever floats your boat, whatever helps you understand just a little bit better. Ooh, this next one's going to be fun. Look at all those negatives in there. Woo-wee! I kind of sound a little bit like Diego and Coco. When he does this little thing at the beginning of his songs and he sings it so cute. All right. -2 is greater than or equal to -4x plus 6. Protect your coefficient and your variable. Remember, we're going to save that for last. How do I get rid of a plus 6? Subtract 6 on both sides. Now I know right here this is going to trick some people up. No shame in the calculator game. If I have -2 minus 6, it gives me a -8 for that side. Does my sign flip? No, I subtracted 6. There was no multiplying or dividing there. Now I bring down my -4x. What's next? Some people, when they see this, they want to add 4. But that's not subtracting 4, that's a -4. That's being multiplied times x. I have to get rid of that multiplication because I'm not subtracting it from anything. So I need to divide both sides by a -4. What happens when I divide by a negative? I gotta flip my sign. So it was greater than or equal to. Now it becomes less than or equal to. Again, this part's probably going to trick people up with the negatives. If I do a -8 divided by a -4, I get a +2 is less than or equal to x. Are we going to have an open or closed circle here? Closed circle on 2. because it has the line underneath that includes 2 in the answer. And what direction will I shade? To the right. X is bigger than 2. So I'm going to shade to the right. Again, let's put this in the calculator just to again see what it looks like. So we found that x is equal to 2. Now I'm going to type in each side separate. I have -2 first for that side. And then my other side I have -4x plus 6. Again, I see both sides are the same. Both sides are the same. It's just the sign that makes things a little bit different. Just the sign that makes things a little bit different. Go ahead, pause the video. Pause the video. Try these two on your own. Again, one of our vocab words, if you want to get rid of that fraction coefficient, multiply by the reciprocal. Pause the video. Try those two on your own. Good luck. Again, I apologize. Because I did not make number lines big enough, I need to make sure I'm checking these problems before I just throw on random number lines. So this first one, you should get that x is less than 10. Open circle because it's less than, and I shade everything to the left because the left side has the smaller numbers. The left side has the smaller numbers. And again, if you put it in this format when you're checking it, x first with whatever direction the sign should be, it'll point to the arrow to the way it needs to go. Here, we get x is greater than 12, so that means we shade to the right. Sometimes on your answer, you might not have the x coming first. So for example, here, if I want to rewrite it so x comes first, x switch sides, so I need to switch that side too. So here I see x is greater than 2 or equal to 2, and I draw my arrow, and that's so I know what way to shade. That only works if x is first, but you've got to make sure you might need to flip signs. If you have any questions with this, let us know. Otherwise, you can go on to the next video to learn about the words that go along with this in translating equations.